Hello everyone, I am Shoputra Panchal, Assistant Professor, Department of Computer Science and Engineering, BLD will be Dr. PG Harkati College of Engineering and Technology, Vijaypur. So in the last class, we have discussed something about the contents of public key certificate, and along with that, we have discussed key storage and on HSM, that is hardware security modules. So how we need to store the keys properly when a particular authorized users wants those keys for their transmission of data. So in today's class, I think we have stopped in the something else, the contents of public key certificate. So and in today's class, we'll be discussing about certificate creation. So location of key pair and certificate creation. Key pair generation and certificate creation, two separate processes here. Okay, in today's class, we will be discussing about certificate creation, the location of key pair and certificate creation. Key pair generation and certificate creation are two separate processes here. So, key pair generation can be performed either by the owner of the public key pair or a trusted third party who may or may not be the certificating authority. So that is what location of key pair certificate creation. So trusted third party generation. So the advantages of trusted third party generation are: the trusted third party may be better placed than the owner to conduct the relatively complex operations involved in generation of the public key pair. The key pair generation process does not require the owner to do anything. So these two are the advantages of trusted third party generation, and the disadvantage of these: the owner needs to trust the third party to securely distribute the private key to the owner. If in any case, if a third party makes a faulty decision, then it will be a problem for the owner. The owner needs to trust the third party to destroy the private key after it has been distributed to the owner. So the second very important point: the owner needs to trust the third party destroy the private key after it has been distributed to the owner. So combined generation. In this scenario, the owner of the key pair generates the public key pair. So the advantages of the first one is, third party generation. Second one is combined generation. In this scenario, the owner of the key pair generates the public key pair. Advantages: the owner is in full control of the key pair generation process. The private key can be locally generated and stored without any need for it to be distributed. Disadvantages again in this is the owner is required to have the ability to generate key pairs. The owner may need to demonstrate to the CA, that is certificate authority, that the owner knows the private key that corresponds to the public key submitted to the CA for certification. That's what disadvantages. So the third one is self-certification. In this scenario, the owner of the key pair generates the key pair and certifies the public key themselves. So in this case, something else owner needs to do, that is the registration of public keys. If either trusted third-party generation or combined generation of a public key pair is undertaken, then the owner of the public key pair must engage in a registration process with the CA before a public key certificate can be used. This is when the owner presents their credentials to the CA for checking. So these credentials not only provide a means of authenticating the owner, but also provide information that will be included in some of the fields of the public key certificate. So that's what registration process that varies greatly between different applications. So that is how we need to register or registration of a public keys can be done. So now the roles of RA, that is registration authority and certificate authority, can be separated for several reasons. So registration involves a distinct set of procedures that generally require an amount of human intervention, whereas certificate creation and issuance can be automated. Checking the credentials of a public key certificate applicant is the most complex part of the certificate creation process. So what credentials should be presented to the RA during registration? So what credentials should be presented to the RA during registration? A very low level of public key certificate might simply require a valid email address to be presented at registration. The registration process might include checking that the applicant can receive email at that address. So the first credential required is email address. Second credential is registration for public certificate for use in a closed environment such as an organization's internal business environment might involve presentation of an employee number. Second one is an employee number and a valid internal email address. So that second credential required is employee number and a valid internal email address. Third one, the commercial public certificates for business trading over the internet might require a check of the validity of a domain name. That is what validity of a domain name and the confirmation that the applicant business is legally registered as a limited company. So this is important here. The third credential required is validity of a domain name. Public key certificate, and fourth one is public key certificates for incorporation into a national identity card scheme require a registration process that unambiguously identifies a citizen. The credentials might include birth certificate, passports. That's what we require for this. Fourth one is what we require is national identity card, and in that there are many examples for such identity: birth certificates, passports, domestic utility statements, etc. So these four credentials should be presented to the registering authority during registration. First one is email address. Email address of the owner. Second one is the employee number and a valid internal email address. Third one is the validity of a domain name. Fourth one is identity. So in that identity, there are many examples: certificates, passports, domestic and utility statements. Then something about proof of profession, proof of procession. Attack on a verification key or a digital signature scheme might work as follows. So let us take directly with the example called as so how attack will be there for a particular transmission. Attack on a verification key for a digital signature scheme might work as follows. The attacker obtains a copy of Alice verification key. So this is a public piece of information, so the attacker can easily obtain this. The attacker presents Alice verification key to an array along with the attacker's legitimate credentials. The array verifies the credentials and instructs the associated CA to issue a public key certificate in the name of the attacker for the presented verification key. So the CA issues the public key certificate for the verification key to the attacker. This is how the proof of procession goes. Then something about public key certificates involve a CA digitally signing the owner's public key together with the related data. So the solution for this is to create a public key certificate for the CA's public key. But who will sign the public key certificate of the certificate authority? The two most common methods of certifying the CA's verification key, which are use a higher level CA. If the CA is part of a chain of CAs, then the CA may choose to have their public key certified by another CA. That is, higher level CA should certify lower level CA. Then the second one is self certification. A top level CA has no choice other than certification. So this is very simple. Then we have key pair change. So at some instant of time during transmission, so we need to change the public and private key pair change. So revocation of public key certificate. So there are some techniques which are there for revocation. One is blacklisting. In this involves maintaining a database that contains serial numbers of public key certificates that have been revoked. This type of database is referred to as a certificate revocation list (CRL). So these CRLs need to be maintained carefully, normally by the CA who is responsible for issuing the certificates. The CRLs need to be digitally signed by the CA and made available to relying parties. Then second one is whitelisting. This involves maintaining database that contains serial numbers of public certificates that are valid. So here it is serial numbers of public certificates that have been revoked but that are valid here in this whitelisting. This database can be queried by a relying party to find out if a public certificate is valid. So this is what completion of key management, that is what we have is fourth module. So in the next class I'll start fifth module, and if you have any queries we'll be discussing it in the my next interaction class. Thank you.